Hi everyone! In this video, we will solve three variable systems of equations. Our system of equations is negative x plus 2y plus z equals 12, z equals y divided by 2 minus 1, and 2x minus y equals negative 10. Now you'll notice that not all of these equations has all three variables. And it might look a little scary at first, but actually it's a little nicer for us in solving because they've done a little bit of the work for us. So I'm going to look through them and see what is the easiest way that I can work this out. So the first thing I see is that the second equation has a variable already solved. And to keep track of these, I'm actually going to label these equations 1, 2, and 3. And I circle the numbers because then I know that that is the equation and it's not a coefficient out in front. And I circle it so that I know that that's always the equation that I'm working with. So I'm going to go to the second equation, and it's solved for z. And the only other equation that has a z is equation number 1. So I'm going to go ahead and substitute equation 2 into equation 1 in place of z. So using parentheses, while I put it in, I'm going to get negative x plus 2y plus, and here's the z, y divided by 2 minus 1 equals 12. Now that I've substituted it in, I'm going to go ahead and combine like terms. I don't have any need for the distributive property for the parentheses because there's just a 1 out there and it's a positive sign. So I can go ahead and drop those parentheses and combine like terms, which would be the 2y and the y halves. So I need to have a common denominator. The first one I can put over a 1, and to make the common denominator, it will be 2, so I multiply the numerator and denominator by 2, giving me 2 times 2 is 4 over 2y plus, let's go ahead and move the y off to the side so that there's a 1 up there. So this is 1 over 2y. Now I could leave the y on top, but just so that it looks the same as the first one, I'm going to move it just off to the side. And the coefficient in front of the y is a 1 because we can always put a 1 in front of any letter. And then everything else is the exact same, so I'm going to go ahead and just keep it. Now let's go ahead and combine. We have 4 halves y plus 1 half y. Now that they have a common denominator, I can add those together, giving me 5 halves y. So this is going to be written as negative x plus 5 halves y. And we have this negative 1, which really should be with the 12 on the right side to combine like terms. So I'm going to go ahead and add the 1 to both sides. That gives me a second equation of negative x plus 5 halves y equals 13. And this isn't a second equation. This is actually a new equation since we have equations 1, 2, and 3 at the top. This is now going to be labeled as equation number 4 because it's a brand new equation that we didn't have at the very beginning. Now I'm going to look at my brand new equation number 4, and I see that I have an x and a y. Equation number 3 also has an x and a y, and this is very similar to doing a system of a 2-variable system with 2 equations, and so I can take those 2 equations, numbers 3 and numbers 4, and get rid of another variable, either the x or the y. So I'm going to put these over here. Number 3 is 2x minus y equals negative 10. And equation 4 is negative x plus 5 halves y equals 13. Now to get rid of another variable, I need to look at the coefficients and see what can I do to one of them to make those coefficients match. The first one, the fourth one, if I multiply by a 2, the 2's will match in front of the x's. So if I multiply by a 2, using this notation, that 2 out in front is telling me that I will multiply 2 times equation number 4. So let's go ahead and write it down here. 2 times equation number 4, and the resulting equation will be right here. So using the distributive property, making sure that the 2 is multiplied to every single term. Don't forget, it also needs to be multiplied to the right side of the equal sign. Many people multiply it to the left side, but always leave out the right side. So make sure you multiply every single term by the number that we've decided to multiply by. So this results in negative 2x, and 2 times the 5 halves will give us 10 halves, which is just 5, or you can think of it as the 2's canceling out. So this is plus 5y, and 2 times 13 is 26. Now I didn't do anything to equation number 3, so I'm just going to write it down just as we have here, which is 2x minus y equals negative 10. Now that I've multiplied those and I set it up that these should match except for one being positive and one negative, they will cancel out that first variable. Negative 2x plus 2x is canceled, and so we've accomplished what we set out to do. Now we have 5y minus y, which gives us 4y, and 26 minus 10 is a positive 16. I now only have one variable, and I can solve for it quickly by dividing both sides by 4, making this y equals 4. So now we have the first variable that we've looked for in our ordered triple. So let's go ahead and write down our ordered triple with 3 spaces, and we can put in y, which is 4, for the middle of the ordered triples because it goes x, y, and z. I know it feels like we did a lot of work to get to the y, and it might feel kind of daunting to find the rest of them, but they go faster and faster. So because I already have a variable, I'm going to go back to equation 3 or 4 because those ones only have 2 variables, and substitute y into one of those. And I usually pick the easiest of the 2 variables so that I have less opportunities to make calculation errors. And since equation 4 has a fraction in there, I'm going to go ahead and just go to equation number 3 just to speed things up a little bit. So equation number 3 is 2x minus y, and whenever we substitute, we always use parentheses, and then fill it in with what we're substituting, equals negative 10. Because I have a minus here, so I have 2x minus 4, I'm just going to rewrite this as 2x minus 4 equals negative 10 so that I can drop the parentheses. And then solving for x, I need to add 4 to both sides. Negative 4 plus 4 cancels, leaving us with 2x equals negative 10 plus 4 is negative 6. And then we will divide both sides by 2, giving us x equals negative 3. And that was really fast to find the first coordinate to our ordered triple. Now to find the last one, we'll take our x and our y that we've already found and substitute it into one of the original 3 equations. And I have 2 equations I can pick from that have a z. Equation 1 has a z, and equation 2 has a z. I will not pick equation 3 since there's no z. And because equation 2 is already solved for z, I'm going to go ahead and pick equation number 2. I could, if I wanted to, also pick equation 1. This would involve substituting x and y. However, for equation 2, I just need the y. So I'm going to set this up, z equals y, substituting it in with parentheses, is 4, divided by 2 minus 1. 4 divided by 2 is 2. And I always cross my z's so they don't look like my 2's. So z equals 2 minus 1, making our last coordinate z. 2 minus 1 is 1. So z equals 1. And now I have all 3 coordinates for my ordered triple, solving our system of 3 variables. And we're all done.